Okay, corn children, this is 6.1 part 2, area between two curves, specifically intersecting curves. All right, so here's the problem. We've been given two curves, f of x and g of x, upside down parabola up 2, and a line. Find the area bounded by f and g. It would be super helpful if we could graph these. Now, here's the deal though. If we have a graphing calculator, I would, of course, use my graphing calculator and graph the two curves, placing them in y equals, and then graphing them. If I don't have a graphing calculator, then we have to do all the work by hand. So I'm kind of doing both of those lessons together. So let's assume, first of all, you don't have a graphing calculator. If you don't have a graphing calculator, you graph these by hand. All right, there's f. It's important that you do label which one is which. Let me slide that up. So this is my f curve. G is the line y equals x. And, oh great, a little longer there. This is the g curve. And you'll notice that these two curves intersect and that they enclose a complete area. It's our job to find that area. Well, the nice thing is, using our previous lesson, we can clearly see that the f curve is the top curve for the whole section. The g of x is the bottom curve for the whole section. The only problem is they didn't hand me limits of integration. So when we go to do this, we're going to integrate the top curve, which is going to be my f of x curve, minus my g curve, which is the lower curve, with respect to x. But we actually have to find the x limits. Well, ladies and gentlemen, the x limits are just the x coordinates of the points of intersection. So if we can find those, we have found these. So just for fun, I'm going to call, let's call this one B and this one A. So we need to figure out what is B, what is A. So integrating from B to A. Probably should have done that backwards. Too late now. All right, so how do we get these? Well, what we need to do is find where the F curve is equal to the G curve. So I'm going to set them equal. To find the limits of integration, we need to find the points, actually just the x coordinates of the points of intersection. And we do that by setting f equal to g. All right, if we're doing this by hand, it is necessary, there's f, there's g, to solve this equation. Yes, that's right, corn children, solving a quadratic. Ooh. We factor, we solve. So as it turns out, b is -2 and a is 1. It's just that straightforward. Now, if I had a calculator, I would not do all this work, but I would need to write down what I'm doing and the answers that I got from the calculator. So these two lines would still need to be stated even if you have a calculator. Now on the calculator, I've already typed them into y equals, and I have already set a window. And once again, we would go into the calculate menu, which is above your trace key. You would go to number 5, which is the point of intersection. You move your cursor so that it is near the point of intersection, hit enter 3 times in a row, and it's going to spit out x is 1. It also gives you the y coordinate, but we were just looking for integrating with respect to x limits. You do the same thing again, but move your cursor near the other one, you get the other point of intersection. So great. So what do we have now? Well, now I know what the area is. The area will be the integral from -2 to an integral of 1, limit of 1. The upper curve is the F curve. The lower curve is the G curve. If I had a calculator, I could use the finite feature on the calculator to do this. If I do not have a calculator, I integrate by hand and evaluate upper and lower. Now, I'm just going to remind you of how to use your finite key. So I'm going to get to my home screen. On mine, there's a shortcut key. I just go to here. So I'm going to do -2 to 1. The upper curve was 2 minus x squared, minus the lower curve is x with respect to x. Hope you can see that. We type it in and my answer is 4.5. So if you want to check your work, provided you're integrating the correct thing, then you can get your answer. The area between these two curves is 4.5. So I'm going to encourage you, when I give you problems to do, try them without the calculator. If solving is a nightmare, go ahead, use your calculator. Our textbook is not great with separating those, so calculator, no calculator. All right, there it is. Area between two curves, finding points of intersection.